right, so let me move this out of my way here. All right, so this is 9.5, and it deals with
Oh,
properties of logarithms. And these are sort of like some properties that are going to help us solve these equations when we hit 9.6 on Monday. So there's a few properties, and the properties are sort of similar to exponent rules, because if you remember, a logarithm in the long run is an exponent, okay? So the first property is what we call the product rule of logarithms. Okay, so the product rule tells me that if I got a product that's taking a log of a product, so the log of x times y, well, when you multiply the variables, when you mess with the exponents, you added the exponents. So the product rule of logarithm says that if I got a product, I can rewrite that as a sum of the logs. So if they're multiplying, I can write them as a sum. Also, I can start with a sum of logs and rewrite them as a single log. All right, so let me bring up number 2 here. And this we call the power rule of logarithms. And this would be like when you had a exponent raised to an exponent, you multiplied them. So the power rule says if I got a log of a number raised to an exponent, then I would take this t, bring it down to the front, and multiply by the log a. So a logarithm raised to an exponent, you basically bring the exponent down to the front and rewrite it as a product. So you're multiplying exponents basically on that one. And then a third main property would be what we call the quotient rule. Of logarithms.
could I ask what the T stands for?
The t,
Yeah.
it just can represent any exponent sitting there.
Oh,
So,
okay. Okay.
so let me show you an example of what this rule is saying. Say I had log of, say, 2 to the x. So what this rule is telling me is that I would bring that x down front and rewrite this as x times the log of 2. But this could be a number or a variable. The 2 could be a number or a variable. So when they sort of give you rules like this and they use letters, they just want y'all to realize that these letters can be any number or any variable.
Okay, thank you.
So if y'all remember now on the quotient rule, when you had variables and you were dividing, like you had an x to the 5 on top and maybe an x to the 2nd on bottom, well, to simplify that, you subtracted exponents. So the quotient rule tells me that if I got a log of a quotient, I can rewrite it as a difference of the logs. The log of the top minus the log of the bottom. And if you notice, basically you're distributing the log to them and rewriting, okay? Now, a few things you should have realized from yesterday. anytime you take a log and that base right there matches the result. So let me explain. So a logarithm, you take this little number that's called the base, and you're looking for the exponent that you would raise the base to get that result. Well, when this base matches that result, the only exponent would be a 1. So if you had a log base 7 of 7, that would equal 1. Log base 10 of 10 would equal 1, okay? Anytime those match, it equals 1. Because on some of these, it's going to play into getting that final answer simplified, okay? Now, they're going to hit y'all with radicals in this section. So I'm going to play with y'all a second and say I had an x to the a with a b in the notch of that radical. So remember, that tells me what the root is, like if I'm taking a square root, a cube root, or a fourth root. And then that's my variable and my exponent on the variable. You're going to have to convert from a radical into a fractional exponent in this section. So what you would do is bring your x over. The exponent by the x is always on top of the fraction. And then the index of the radical or the root is always to the bottom of the fraction. So if you had a square root of x, to rewrite this would be x. Y'all, there's not a number by the x, so I got to treat the top number like a 1. And I don't have a number in the notch. So anyone remember what number is in that notch if there's not a number in there at all?
If there's not a number, then it's usually a 2.
It's a 2. There you go. So if it's radical by itself, it's just what, a square root radical? But remember, if you had a number under here, you could also take the square root of it by using the fraction form. Okay? All right, so that should be enough of the, I just wanted to recall you on these last 2 little stars I got. So let's play with some of these and see what they want to do. This first example wants me to express as a sum of logarithms. So if they want them to end up as a sum of logarithms, the only way they can end up as a sum of logarithms up here is if I started out with a product. So let's see what they're giving us. They're giving us log base 6, and then in parentheses got 6 times 36. Now, they don't want me to simplify these. They just want me to rewrite it as a sum. So since this is a log base 6, we're basically going to distribute it to both of these. So I'm going to have a log base 6 of 6, and then plus my log base 6 of 36. Now, had this said express as a sum and simplify, then I would have started trying to find the numbers that these equaled. Like log base 6 of 6. The exponent you would raise 6 to turn that into a 6 would be a 1. So that part would equal 1. And in the second part, what exponent would you raise 6 to turn into 36? Well, 6 times 6 is 36, so that would be a 2. So this would have been a 1 plus 2, which I could have added to get a 3, okay? But they didn't want us to do all that. They just wanted us to rewrite it. And then we got an ln of an xy. So y'all, real quick, let me explain the difference between a log and an ln, okay? So I'm going to write this up here. If you got a log by itself and it don't have a number here, we treat it like a log base 10. And if you'll notice on front of the calculator, on the left side by the 7, you got the log button. So that's going to do the log base 10s, okay? It's going to find exponents that you would raise 10 to get those numbers. LN is a special log. LN would be what we call a natural log, and it's a log base E. Now, E is just a number like pi. It goes on forever and ever. Actually, let's see. If you see by the division sign, there's a little E there. So if I hit the blue button and the division, it brings up the E, and I hit enter. Notice it equals like 2.718, blah, blah, blah. They got that number from doing, oh, what was it called? Compound interest type problems. But it's just a number like pi. We call that a constant, okay? So the LNs are the base log E's, and the logs are the base 10s, okay? So all we want to do on this one, though, is rewrite it as a sum. So that'll be a ln of x plus ln of a y. Okay, so I just wanted to show y'all really what ln was, because that might have been tricky on them videos. All right, y'all, let's turn over and work the next few examples. And these ones want us to express as a product. So when I'm done, I'm going to have things that look like they're being multiplied, which means we're going to be using the power rule. They're going to give me exponents, and I got to bring them down and rewrite it as multiplication. So this would be like number 3. It is a log base 10 of y to the 16th. And really on that, they didn't need the parentheses. I don't know why they did that on that. But remember, to rewrite it as a product, I got to take this exponent 16 and bring it down to the front so that this gives me 16 times log base 10 of the y. So on this one, we move exponent to the front. And rewrite as multiplication. So you got to love these one-step problems. Although number 4 gets a little trickier, y'all. This is a ln of the 5th root of a 3. So to start this problem, this is the one where I was showing you you had to rewrite the radicals, because we don't know what the exponent is in this form. So what we got to do is rewrite this without the radical. So it's going to be ln 3. And remember, radicals rewrite as fractional exponents. There's not an exponent by the 3, so we would treat it like a 1, which means the top number is a 1. And then this one does have a number in the notch, so the bottom number would be the 5. So your first thing you had to do was convert from the radical to fractional exponent. Now I can see I got an exponent of a 1/5. So now I got to take the 1/5 and bring it down to the front so that this gives me a 1/5 times the ln of 3. So of the 4, that's the trickiest one because you have to convert my radical, okay? expressed as a difference of logs. So if I'm going to express them as a difference, when they start, they're going to have stuff looking like it's being divided. So number 5 has log base C of D divided by 7. And y'all remember on these, it's always the top minus the bottom. And if you notice, I'm still distributing my log base C. So this one would give me a log base C of D minus a log base C of 7. And y'all be careful on MATLAB when you do these. You got to use the subscript for these C's on this, okay? The subscript looks like the box, and then have a little blue box down below, okay? All right, same thing. Let's see. If you notice, I'm giving you one log and one natural log on every one of these. So 6 will be the ln of V divided by W. See, all right, same thing, right? Take the ln, distribute it. So you get a ln of V minus ln of a W. And here's another thing. When you're doing these on MATLAB, those are not capital I's. They're small L's. Okay, those are ln, log natural, I guess you would say. But a lot of people miss it because they put the capital I on the answers, and it will mark those wrong, okay? Those are small L's. And
If
actually,
you
when
want,
you
oh,
I
could
was
you
going to say,
reverse?
do what now?
Could you reverse it and say LNW minus LNV, or does it have to be in that order?
No, it has to be the top minus the bottom.
Okay.
Because what happens when things are on the bottom, their exponents are negative.
Oh, okay.
And then that's why we sort of use the quotient rule from the old exponents that when y'all using those rules. So always remember, it's always going to be that top minus those bottoms on those, okay?
Okay.
So now that we know those 3 main properties, they're going to start mixing them up. So my number 7 says rewrite as sums or differences of logarithms. And we're just going to call them logs. So all 3 properties will apply to these, okay? So this one, number 7, has log base B of x to the 3rd, y to the 6th, z. So y'all, the first thing we got to do is these are all being multiplied. So when I rewrite this, it's going to look as a sum. The sums come from the products. The differences will come from the division. And I'm going to distribute my log B to all 3 of those. So I'm going to get a log B of x to the 3rd plus my log B y to the 6th plus my log B of z. So every factor has to be split into this addition. So now, one more thing I got to do to these. And y'all see the ones that have these exponents? I've got to use this power rule up here and bring these exponents down to the front. So the 3 will go down to the front of log B of x, and this 6 here will go in front of the log B y. So that when I rewrite that, I get my 3 log b of x, plus this one will give me a 6 log b of y. And then I didn't change that, and so it's just going to come down as a log b of z. That would be our final answer. So once you get it rewritten as a sum, these exponents also have to be brought down using the power rule, okay? We're not allowed to leave exponents up there. So these are a little tricky at first, but you get used to them. Well, I'm going to turn the page on this next one, y'all. So we're about to do a fun one, okay? So it'd be what, number 8? Okay, here we go. We got a log b. On top is a P3Q7. On the bottom is a M5B7. So I've got a log base B, and then my fraction is a P3Q7 over a M5B7. So technically, let me put parentheses so y'all don't get the B is not under the fraction, it's the base of that logarithm. So when you got something like this and you rewrite it, if it's on top, the sign will be positive. When I rewrite it, if it's on the bottom, the sign will be negative. Right? Because products got rewritten with addition, but really these two products down here, you would start out being added, but in the long run, since they're on bottom, you're going to be subtracting them anyway. So what I do when I find something like this, I rewrite it as a log b of p to the third plus a log b of q to the 7. So both these that were on top, notice I kept them positive like I said here. Now, since the rest of these other two factors are on the bottom, they're going to be subtracted. And that'll give me a log b of m to the 5th minus a log b of b to the 7th. So fractions, tops are positive, bottoms get subtracted. So now let's think about this. Everybody's got exponents, so all 4 exponents have to be brought in front of their logs. Okay? So this will give you a 3 log b of p. This one you bring down to 7, you get a 7 log b of q. Bring down to 5, so that'll be minus 5 log b of m. Minus, bring down the 7 at the end, 7 log b of b. So y'all, we are happy all the exponents are brought down, but I will say this. This problem has one more spot where I could simplify it. And it's going to be the one, so let me find my notes where I wrote that at. Oh, that would be like this little property I had here. Log base A of A equals 1. Anybody look like that down here? If you notice, I got a log base B of B over here. Well, this log base B of B part is going to equal 1. And 1 times negative 7 is just going to make that a negative 7. So I got to rewrite this now. So they all stayed the same because nothing matched on them. But this one, since the log b of b equals 1, 1 times -7 made that a -7, and the log is gone. Okay. All right, y'all. So that's probably one of my trickier ones. Let's see, number 9 does the same thing, but it's using ln. ln of 6 divided by 7 x to the 7th y. So one of the first things you got to realize is you got the 6 on top, but on bottom you got 3 factors. You got a 7, the x's, and the y's. So all these, when I rewrite them, if they're on bottom, they're going to be negative, and on top, they'll be positive. So I'm going to follow the same rules, distribute my ln, so I get a ln 6 minus my ln 7 minus my ln x to the 7 minus my ln of a y. And y'all, this one only had one more move to do. And that's take this little 7 and bring it in front of its ln. So rewriting all this, I get a ln of 6 minus ln 7 minus, that would give me 7 ln of x, and then minus my ln of a y. So I will say one thing that makes these questions a little trickier is they don't never really get smaller. We're rearranging stuff, but I don't never get a single answer out of these. It's just simplifying them and making them a little smaller. All right, here's a good one for you. Log, and y'all, this has a radical. Underneath the radical is a c to the 9th and a d. So the first thing I got to do is get both of these out from under that radical. So the radical does affect both of these. So this is going to be log. So there's not a number for my log, so this has to be a log base 10 when they don't show you the number. All right, so let's see. C, it's got an exponent 9. But I need to know what that number on the bottom is, and y'all told me that if there wasn't a number here, it is a 2.
2.
Mm-hmm. And then how about the D? The D don't have any numbers. So the D's missing a number. I would probably put, what,
So
a
it's
1
just
there? Mm-hmm. So that D would be a 1/2.
1/2.
So you got to remember, that radical affects everybody under it. So I had to rewrite both of those using my radical. Now, since they're being multiplied, we will rewrite this as a sum. So log c to the 9/2 plus log of my d to the 1/2. All right, so they both got the same log. The only thing I'm worried about on these numbers now are those exponents. So both of these exponents will get moved to the front. So that this one gives me 9/2 log c plus this will be, what, a 1/2 log d. Okay, so the main thing, and we got a big one coming up, but just remember, everything under that radical is affected by the radical. All right, y'all, number 11, we're going to have to flip. Number 11 is a good one here. And I will say, they like putting one like number 11 on these tests and the finals, okay? So number 11 has a log base C. Whoa, and it's so big they put big parentheses here. It's got a big radical with a 4 in the notch. So this is a fourth root. On top is an M16N20. On bottom is a C5, A5. And then all that in parentheses. So the first thing I'm going to do is rewrite everything about that big radical. So I'm going to bring my log base C over here, and I'm going to have a big fraction still, but I'm not going to have the radical. So all the exponents for these variables are all going to be divided by 4. So you got an M, 16 divided by 4, but 16 divided by 4 will reduce to a 4. We're going to N's. N, we got 20 divided by 4. Well, I can do that one also. 20 divided by 4 would give me a 5. Now down here we got a C. It's got a 5 divided by 4, which I cannot simplify, so I'm going to leave that at 5 over 4, okay? And then let's see, the A, same thing, it's got a 5, and 5 will not divide by 4, so I'm going to make that a 5/4. All right, so what I did here is I rewrite as fractional exponents. So now I'm ready for the sums and differences. If it's on top, it's going to be positive. If it's on bottom, it's going to be negative. And I'm going to distribute log C to all 4 of those. So I'm going to get a log base C, M to the 4th, plus log base C of N to the 5th. These two are on bottom, so they're going to be subtracted. So that'll be minus log C, C to the 5/4, minus log C of A to the 5/4. All right, y'all guess it. We're about to take all those exponents and shoot them down to the front. So watch this. This one gives me a 4 log C of M plus my 5 log C of N minus 5/4 log C of C minus 5/4 log C of the A. Woo, a lot of writing on these, right? And y'all, unfortunately, this one had one more step. So look at all your logs. Log C of M can't do nothing. Log C of N can't do nothing. But look here, a log C of C. I know that this log C of C equals 1. And 1 times negative 5/4 is just going to make that part a negative 5/4. And then here I can't do nothing. So I'm going to rewrite this as 4 log base C of M plus 5 log C of N minus 1 times 5/4 is a 5/4. And then at the end, minus your 5/4 log C of A. So that's the main part where I get people is they forget to convert the log C of C to a 1. And that although you're got the right answer, it's not what they would consider the most simplified right answer, okay? All right, so we're ready to go the other way. We're going to express as a single log. So we're going to start out with 2 logarithms or more and rewrite it as a single log, okay? So this one has number 12. I got log C of 22 plus log C of 45. All right, so I know since they're being added, I'm going to write this as a product. So log C, the product would be 22 times 45. Now, I know what 22 times 45 is because I got my calculator here. So let's see, 22 times 45 would give me 990. So my final answer would be log C of 990. So if they're being added, write them as a product and then multiply that product and see what you get. All right, watch this one. This one wants me to express as a single log. And simplify. All right, y'all, so let's see what I got. I got a log of 1,000 minus a log 100. Now, we know since these are being subtracted, I rewrite it as division. So this would be a log 1,000 divided by the 100. Well, I can divide 1,000 by 100. Should be what, a 10 right there, right? So this is a log 10. But y'all, since there's not a number here in the log, remember that is a 10. And the log base 10 of 10 equals the final answer of 1. And y'all watch this. Here's a calculator, log. Punch in that 10 and enter. You get a 1. Now, I'm not sure if y'all, yesterday when y'all was doing this, but when you had the logs with the numbers and the bases, y'all could have hit math and it's arrowed down. And it has log base. So you hit enter on log base and it'll pull them up. So you can put a 10 there and then what, a 10 there and hit enter and get a 1. So the ones on the calculator, this log does log base 10s. LN does the natural logs base E. Any other log, you got to hit math and go down to the log base, okay? Then you can put in numbers like 3 and 9. And when you hit enter, you should get a 2, right? Remember, this finds exponents that you raise the base to get those results. All righty, but that's what they meant by simplifying, go all the way till you couldn't go no more on that, okay? All right, this has the same rules we just went through. So we're going to turn it up a little bit. How about a 1/4 log C of X plus a 5 log C of Y minus 4 log C of an X. All right, so working in reverse, the first thing I would probably do is take all these exponents and shoot them back up to their variables. So let's give the variables back to their exponents. So that this gives me a log C x to the 1/4 plus log C of y to the 5th minus log C of x to the 4th. So when you rewrite it as a single log, you do pretty much everything we did a while ago in reverse, okay? So now, these are being added. I'm going to rewrite them as a product, but this one's being subtracted. So it's going to go to the bottom of the fraction. So here we go. We're going to have a log base C. These two are positive, so they're going on top. So I get an x to the 1/4, y to the 5th. This one's negative, it's going to the bottom. So this will just be what, x to the 4th. So I took the log C out, put it in front, and then positive went to the top, negative went to the bottom. So remember, positive goes to top, and negative goes to the bottom. We would technically be done, but y'all look at this. I got an x on top and an x on bottom. We can use the quotient rule to simplify this. So y'all, here's a question. When you're simplifying variables, you find where the largest exponent was. So you got a 1/4 and a 4. The larger exponent is the 4 on the bottom. So what you would do to simplify this is subtract this 1/4 from this 4 and keep that answer on the bottom. Variables stay where the larger exponent was when you're simplifying. So what would happen on top would be the y to the 5th. The bottom will be an x. So to find out how many x's, we got to take that 4 and subtract 1/4. So we got calculators now. So the easiest way is to say 4 minus 1 divided by 4. That's going to give me 3 something. Remember, turn that back into a fraction by hitting math and enter twice. And you get a 15/4. So this equals x to the 15/4. Now remember, if you're doing them by hand, you'd have 4/1 minus 1/4. Common denominator would be a 4. So multiplying this by 4 and 4, you get 16/4 minus 1/4, which would be a 15/4. But hell, that calculator knocks them out, and y'all are able to use those. So, well, I sure curve that paper a lot, don't I? Must be my hands get a little wet and it starts curving it. All right, but that was my final answer because I had y's on top, x's on bottom. Can't go no further. So I'm bringing back all the memories, ain't I? Here we go. ln x to the 3rd minus 5 ln 5th root of x squared. Make sure I wrote all that right. All righty, and then this one wants me to simplify if possible, okay? So first thing I would do is probably rewrite this one out of the radical, okay? So I'm going to bring down this ln x to the 3rd minus 5 ln. This one would give me x. Exponent would be 2 divided by the radical, which is a 5. So rewrite without the radical. Now I'm going to take this 5 and bring it up. So this is going to stay a ln x to the 3rd minus ln x. Well, what's going to happen when you bring that 5 up? 5 times 5, 5 times the 2/5. What's going to happen? Those 5s are going to cancel, and that's going to equal 2. So this just becomes the ln of x to the second. Okay, so when you bring them up, if there's an exponent, multiply them. And y'all, here we go. 5 times 2 divided by 5 is going to give me that 2. So now rewrite them as a single log. They're being subtracted. So this will be a ln x to the third on top because it's positive. X squared on bottom because it was negative. All right, to simplify that, this has a bigger exponent on top, so my answer will stay on top. And then 3 minus 2 leaves me an x to the first. But remember, we don't have to write that 1 on these. It's understood to have that 1 there, okay? All right, let me let y'all catch that up, and we got a couple more of these. I'll probably make it an easier day on y'all today because y'all have a test some of y'all got to do, and I want y'all to learn this stuff good before we hit the equations on Monday, okay? All right, y'all, so here we go. A ln in parentheses x squared plus 6x plus 8 minus a ln of x plus 4. So nothing I can do inside either one of these parentheses, so I'm going to rewrite this as a single log. And since this one's being subtracted, it's going to the bottom. So bring out the ln to the front. We know it's going to be a fraction because this part's positive and this part's negative. On top will be the x squared plus 6x plus 8. On bottom will be the x plus 4. So now we got to factor the top to see if it simplifies. So on bottom was what, an x plus 4? So if a problem like this is going to simplify, one of these two factors has to be an x plus 4 so I can cancel that out. So let's see what happens with the x squared plus 6x plus 8. I know in front would be an x and an x. Since that's positive, both of these will be positive like the middle sign, so they're both positive. So there are factors of 8 that add to get 6, and hopefully one of them is a 4. So that would be what, a 4 and 2, right? 4 times 2 equals 8. 4 plus 2 is 6. So this would be a 4 and a 2, which means we can now cancel out the common factor x plus 4. So your final answer is ln x plus 2. Okay, y'all, that's all you're doing on that. And just remember, anytime you got trinomials like this, x squared plus 6x plus 8, you got to factor them to see if factors will cancel on these fractions, okay? Oh, here's another good one. So we trying to keep you honest on your factoring, I guess. So this one has a log x squared plus 8x plus 12 minus a log x squared minus 36. So just like this problem I just did, I'm going to rewrite this as a single fraction. Log on top, I know is going to be the x squared plus 8x plus 12. And then the bottom will be the x squared minus 36. So y'all, guess what? Both of these will factor into parentheses. So the top, you got an x squared, that's an x and an x. That sign's positive, so both factors will be positive like the middle number. Factors of 12 that equal 8, let's see, 6 and 2. Right, 4 and 3 equals 7, 12 and 1 equals 13. So the only ones I could use was the 6 and the 2. The bottom, you got an x squared, so that's an x and an x. The last number is negative, so one's positive, one's negative. So I can tell the only factor that's going to cancel is this positive one. Either it's going to be a positive 6 or it's going to be a positive 2. Now, since there's not a number in the middle, we find factors of 36 that subtract and get 0. Well, 6 times 6 is 36, and 6 minus 6 is 0, so that'll give me a 6 and a 6. Actually, this thing is called the difference of perfect squares. You basically take the square root of the last number to get the two numbers, okay? So if that was x squared minus 25, I'd put a 5 and a 5. But if you notice, x plus 6 here cancels with a x plus 6 right there. So my final answer would be a log x plus 2 over x minus 6. Now, this one I wouldn't have to put my parentheses in the MATLAB, but y'all, this one I would, because you got two parts and you got to keep it in parentheses. This, since it's under the one fraction, it treats it as one answer on that, okay? All right, y'all, so that was properties of the logarithms. So what we will do Monday, I will pick up in, we'll knock out 9.6, which is solving equations. And then 9.7 is doing a few word problems. Tuesday, I'll review. Wednesday, you'll have your test 4. And then Thursday, we'll have the final exam. And I'm going to study for it on Wednesday also, okay? So Wednesday, although this test is going to open up that day, I'm going to use this day for really knocking out that final exam study guide.
Okay.
So let me stop this share. And I set it up so that y'all would have more slack at the end than in the beginning, you know. I'm gonna stop this.